Okay guys, so this is the Cell Respiration Lab. We've got our data table and we have our lab sheet, the directions like this. And we have a group that already has a couple of setups ready. They've got their 4 vials with the cotton balls at the bottom. They started with the absorbent cotton on the bottom. They soaked with KOH, or potassium hydroxide, and then they put the non-absorbent cotton directly on top of that. And then they're getting ready, like these are mung beans. Aren't those so cute? They're germinating mung beans. And they're working on displacing, right now they're doing the non-germinating mung beans and finding equal volume. So the ready setup A, you can see the mung beans on top of the non-absorbent cotton. The second one is the non-germinating mung beans. You can see the difference in them. And that has the beads so that the volume of both of those respirometers is equal. And then they're ready to do C and D. Now the third respirometer setup, you can see that they are using barley seeds. I can barely say that, barley. And then so they decided to use barley seeds instead of alfalfa seeds. And so they're shaped a little bit differently. So they have their 25 barley seeds, 25 non-germinating mung beans, 25 germinating mung beans, but the beads are because the volume has to be equal to respirometer A, the first one. The fourth respirometer is beads only. That's our control. And you can see that the pipette is inserted. Those look really good. They're going to tape off the openings so that we don't have any water leaks. And we're going to soon put them in this beautiful water bath. You can see this beautiful tape job. Look at that. They are not going to leak. Not going to leak. And they're about ready to put them in the water bath to equilibrate them. So they're going to put washers on the tips of their pipettes to hold them down. You can see it's going to take 3 washers. This will weight them down so that they stay in the water. Very nice job. Yeah, I do them all. Did I not give you enough? I got to get some more washers. Okay, so we've got all 4 respirometers. You can see beautifully in the water bath. The tips are sticking out because they are in the process of equilibrating, trying to like equal everything on the inside because, you know, they're very subject to changes in pressure, temperature. So they're going to leave them here for 2 to 3 minutes. Okay, so they are under the water. They are submerged. They are reading the movement of the bubbles. I don't know if y'all are going to be able to see it. I'm going to have to give you the data on this. But you can see, yeah, I see it. The bubbles are super tiny, like right there.
Oh, that one's gone.
Yep.
Oh, that's not.
So you'll see that moving. So I'm going to give you guys data on the other end of this video because we're not going to record it live. But here, I'll let you see this one. There's that one. Yeah, these are good. There's that one. Okay, so for the data for our Cell Respiration Respirometer Lab, I'm going to show you the first numbers, the initial volume. We're going to go right here for setup A with our germinating mung beans. The initial volume of our pipette is 0.71. The initial volume of our pipette for setup B, the non-germinating mung beans and the plastic beads, is 0.78. And then for setup C, 0.81. Setup D, 0.75. And setup D is our control. This is the beads only. So now after our 3-minute incubation period, you'll notice setup A went from 0.71 to 0.65. So first thing we want to do is record that change in volume. Okay, so that change in volume that's 0.06. Let me see if I can write this right here. That's a 0.06 change. Okay, the change in volume in setup B went from 0.78 to 0.77, so that's a 0.01 change. Setup C went from 0.81 to 0.79. That's a 0.02 change. And then we did have some movement in our setup D. You can see that that was a 0.01 change. So what we have to do now, I'm going to show you guys how to do the math. Because this is our control, setup D, and this technically should not be moving, we have to take this change that we have right here, which is a 0.01, and we're going to subtract that from the change in volume of each setup. So we're going to take 0.06 minus 0.01, and that gets our adjusted volume as 0.05. If we take this 0.01 and we subtract the 0.01 that our control changed, then we get a 0, adjusted volume of 0. If we take setup C, we get an overall change in volume of 0.01. So we have to do that. We have to account for a change in our control so that we can get what's called the adjusted volume, how much really we have the consumption of that carbon dioxide in cellular respiration. So for our third measurement, we did a 6 minute time frame, 6 minute snapshot. So you can see setup A, we went from, and we're not going to go from 3 to 6 on this one. Watch what I'm going to do. We're going to go from 0 to 6 because we're looking at the 6 minute time frame. So to do the math, we're going to take 0.71 and subtract 0.61 from that to get our change in volume. So that means our change in volume is 0.1, and I'll go ahead and keep it to the hundredths place. I'll put the 0.10. But we still have to account for the adjusted change in volume. So we have to look over here, look at our control. This time we didn't have any change, but still from 0.75 to 0.74, it's still a 0.01 change in volume because we go from beginning to the new measurement. So I take that 0.01, I come back over here, and I'm still going to subtract 0.78 to 0.77 is a 0.01 change. But because this one is also 0.01, I still get a 0 for my adjusted change in volume on that one. Okay, so you guys see what we're doing with the math? For the setup C, we went from 0.81 to 0.77. Okay, so that's going to be a 0.04. And then we have to subtract the 0.01 from that, so this is now a 0.03. Okay, so can you see what we're doing? All right, so for the rest of this, I'm just going to give you the measurements of what happened, and then you complete the rest of your math. So these are the rest of your numbers. There's setup A. So there's your 9 minute is 0.52, your 12 minute 0.49, and your 15 minute 0.40. Setup B, 0.75, 0.74, 0.72. Setup C, 0.70, 0.67, 0.61, and then there's setup D. Okay, so I'm going to let you go ahead, do all the math, figure out your answers, and then follow the directions down here. You're going to calculate the respiration rate over the 15-minute time frame, and then on the back, you guys need a graph and answer the questions. Okay, when you're finished, go ahead and take a picture, PDF, save it as PDF, and then upload it to Schoology.